people. Let us look at this question, the compound bar. We are given compound bar. You are having a bar, it's hanging on its ropes and all that. The below diagram show two wires supporting a weight of a W, supporting this weight of a W. Right, supporting this weight of a W. The upper end of the wires are firmly secured. Yeah. The left hand wire is a copper wire. The left hand side of this, it is copper with the diameter of 3 millimeter, and the right hand wire is a steel with the diameter of, then the diameter of this right hand side steel, it is 2 millimeters. Okay, both wires are exactly 4 meters. The length of this wires, it is 4 meters. Both wires extend the same amount. E for steel, we are having the E of steel, it is given as 200 gigapascal, and that one of a copper, it is given as 100 gigapascal. Okay, now the first question here, they want us to calculate the position. Now they want us to calculate the position of W on the horizontal bar so that both wires extend the same. Now they want us to calculate the position, but we know that from this wire to that wire, we know the distance from here to there, it is given as what? As 600, the distance in between. But we don't know there what is that distance. We will therefore denote it as x because we don't know the distance from here to there. Okay, and we don't know as well the value of your W at this moment. Okay, we don't know the value of your W at this moment, but that's not important. Now we then have to determine the position. In determining the position, firstly, this it's a parallel connection. It's a parallel connection. What is it that we know about the parallel connection? We know that XC equals to XS. That we know. We know that force total equals to force S plus force C. In this case, the force total would be our what? Our W. That means we are having a W equals to Fs plus Fc. That we know. Now, in solving this or in determining the position, we then have to determine the forces that are acting on your copper and on your steel. We will be using the the equilibrium principle to solve this, moment of a force to solve this, bending moment principle to solve this. Okay, now we know that change in length, we know that we are having Fs Ls equals to As multiplied by Es equals to Fc Lc over AC EC. The L and the L will cancel out. We are going to make Fs the subject of the formula. Then we'll cross multiply, then we'll have Fc multiplied by As multiplied by Es divide by AC EC. Now, we know that the area, the pi and the pi will cancel out, the 4 and the 4 will cancel out, then we'll be left with diameters. That's the route that we'll be taking. Then here we know that the gigapascal and the gigapascal will cancel out, the zeros will cancel out. That means here we are having Fc multiplied by the diameter of your steel, it is 2 squared multiplied by 200, that would be gigapascal, divided by 3 squared multiplied by 100 pascal. This cancel out, the 0 and the zeros will cancel out. Then we are left with Fc multiplied by 2 squared multiplied by 2, of which it will be 4 multiplied by 2, it will give us 8. That means here we are having 8 divided by 9, because 3 squared it is 9 multiplied by FC. Then we get our FS. We will get our F as 0,889 FC. Then we'll make this equation number 1. Okay, this is what we have. We got this from the manipulation of the formula. We still have to determine the force that it is acting on your copper and the force that it is acting under your steel. Now, this it is the manipulation from the formula. This can be the force acting here. This it is firstly the manipulation from the formula. Okay, then let's come on this formula. This is our equation 1. Then let's come here. We are having a W equals to our Fs, it is 0,889 FC. Then we will substitute, we'll make this equation number 2 or equation number 1, it doesn't matter. We'll then substitute Fs into this formula. Okay, our Fs, it is 0,889 FC. Then it will be 0,889 FC plus Fs plus FC. Then we get our answer here as 1,889 FC. Our W equals to 1,889 FC. Then we can make this the third formula. Now from the third formula, we can then determine the forces that are acting on this diagram. Let's use the other page here. Okay. And using the other page, remember the third formula, we are having W equals to 1,889 FC. Okay. Now, let us go ahead and make FC the subject of the formula. That FC that we are making the subject of the formula, it will be now the force that it is acting here. It will be the force that it is acting on this rope here, the FC. That's the one that we'll be using when we will be applying the equilibrium principle to determine the position of the W. What do I mean by equilibrium? Take moment at some of the clockwise forces equals to some of the anti-clockwise forces. We'll be using those principles. Some of the upward forces equals to some will be used. Those are the principles of what? Of your equilibrium. Okay, but let's go ahead and calculate the force that it is acting on that wire there. Now FC would be 1, it will be 1 divided by, remember when you divide both sides by 1,889 in making FC, you will have 1 divided by 1,889 multiplied by W. Then I get my answer as 0,529 W. This is the force that we'll be using, or this is the force acting on that wire for us to be able to use the principle of equilibrium in determining the unknown distance there. Then we are going to say, therefore, substitute this into that formula. Substitute this into this formula here. Into formula number 1. We will be substituting the FC into formula number 1 so that we can get this force, the force that is acting on the steel wire. Right. Then we are having Fs. We are having the Fs as Fs equals to 0,889 FC. Okay, that's what we have there. It will be 889 FC. We're then going to substitute this into that so that we get the force acting as I've explained. The 0,889 FC, it is multiplied by 0.529 W. Then we get our answer. Then we will get our answer 0,529 471 W. Now we've managed to determine two forces acting on those wire. We can then take moment. You can decide where do you want to take moment. You want to take moment at FC or you want to take moment at FS. It is up to you. Now when we take moment, let's start by taking moment at FS. In taking moment at FS, let's wipe a bit so that the picture can be clearer. Let's wipe so that the picture can be clearer. Right. When we take moment, okay, when we take moment here, we are having an upward force here. We are having an upward force here. They are going up. Since all this one is going down, these two are going up. Now, if we take moment here, we will then determine the direction of this force, if it is rotating clockwise or anti-clockwise. Now you can tell that from where you have taken moment to this force is rotating what? Anti-clockwise. And this force here, force copper, it is rotating what? Clockwise. Now, when we take moment here, it will be W multiplied by X, because the distance from here to there, we did say it is X. But this one, FC, multiplied by the distance. Now the distance from here to there, it is what? It is 600. Now it will be, let's write it here. Now we then have to indicate, take moment at FC, take moment at FS. Then we are able to determine the direction of the forces, if they are rotating clockwise or anti-clockwise, using the moment of a force. Like I said, if we are taking moment at, then we are going to have FC. We are going to have FC. Remember, there's FC acting here. It will be FC multiplied by perpendicular distance. The distance there, it is 600. Now let's go ahead and write it. It is FC. It will be FC multiplied by what? By 600 equals to W multiplied by what? By X. But what is our FC? This is the FC. This is the force on your FC. Then we are going to substitute the FC with that force acting there on that wire. It is 0,529 multiplied by W multiplied by 600 equals to W multiplied by X. Right. Then the W and the W will cancel out. Then you are able to determine your X. Your X would be 0,529 multiplied by 600. Then it gives us the answer as 317,4 millimeters. We've then managed to determine the distance. We've now managed to determine the distance. We've now managed to determine this X. We know that from here to here, we know that from here to here, it is 317.4 millimeters. We've determined that. Then the remaining from here to there, then you would say 600 minus that, then you are able to get the distance from here to there. But let us now take moment. We took moment at FS. Let's take moment now at FC. If we are taking moment at FC, it doesn't matter. Let's look at the diagram. If now this is where we have taken moment, we are able then to determine, we will be rotating towards where we have taken moment. This force here, its direction, it is what? It is clockwise. Then this force here on F, as it is what? Anti-clockwise. Now let's establish the force multiplied by perpendicular distance there. It will be W multiplied by the distance from here to there. It will be 600 minus X. The distance from here to there, it will be 600, the whole 600 minus X. Then you are able to get that distance there. Then on the FS, it will be FS multiplied by the whole distance from here to where we have taken moment. It will be 600. As long as from here to there we are clear that it is 600 minus, then we'll be able to determine that. All right, we've then taken moment. Then it will be W multiplied by 600 minus X equals to On the other side, we said it that it will be Fs multiplied by the whole distance 600. But what is our F? The force that is acting on the Fs. The Fs, it is this. That means we will substitute the Fs with 0,471 W. Then we are having 0,471 W multiplied by 600. Then this side it is W, 600 minus X. Now the W and the W will cancel out. Then we'll be having 600 minus X. Then 0,471 multiplied by 600. Then it gives us what? It gives us 282,6. Therefore, when we transpose this to the other side and transpose that, then we are having x equals to 600 minus 282,6. Then our answer, it is 317,4 millimeters. Right. Now, this would be the position of your W. This would be the position of your W. This is how you determine the position of your W. Now, the second question, they are saying determine the force in each wire if W equals to 300. That one, it is easy in solving it. We've already managed to establish that our 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 FC, it is this. Then our Fs, it is this. Now we are told that W is 300. Now in determining the force, it will be Fc equals to 0,529 multiplied by 300. Then you get your force. And our force there would be our force on Fc. The force on Fc, it would be 158,7 Newton. Then when you minus this from 300, then you will get the Fs. But if you want to multiply by W, it doesn't matter. You'll get the same answer. It will be 0.471 multiplied by 300. Then you will get your answer as 141,3 Newton. Because when you add this and that, they must give you the force total of 300. Then the third question and the last question, they want us to calculate the extension. We know that SS equals to XC. Whether we use everything that has to do with steel or copper, the answer would be the same and the correct one. Now it will be XS equals to XC equals to FL over AE. Then when you substitute, you are having the force. It doesn't matter which force do you want to work with. If you want to work with the force of your steel, we did determine it, or the force on the copper, we did determine it. Then multiply by the distance, it is 4 meters. Whether you use the area of a copper or of the steel, it doesn't matter. Whether you use the Young modulus of a steel or a copper, it doesn't matter. Your answer would be the same and the correct one. And in this case, our extension would be 0,898 millimeters. Right, you can work it out and prove it if it is so. This is how we tackle such question, good people. Thank you, good people. But before we go, let's look at those questions here. Please write them down. Let's look at them. You can write them down and start attempting these 3 questions. A load of 20 kilonewton is carried by 3 wires. Now please attempt this question. All right, I'll give you time so that you can be able to pause and write the questions nicely. So now a load of 20 kilonewton is carried by 3 wires with the same length of 5 meters. All the wires have, now we are dealing with the same concept as the previous question, but this time around we are having 3 wires, 1, 2, 3. Then we are having a force acting on that. Then the force, now they don't want us to calculate the position. Now we assume that the force, it is at a middle, the W is at a middle. This would be your force total. Then you are having, whether this is steel, copper, or aluminium, or this is steel, or this is steel, copper, it doesn't matter. The principle, it is still the same. This is the parallel connection. Now you can attempt this question. Then if you want answers to this question, just let me know. Just leave the comment there to say, can I get solution to this problem? Then I will definitely drop the solution to this problem. Thank you, good people.